All right, so we have a sled starting at the top of a hill. A boy coasts down a hill on a sled. So we got the object starting up here, and it slides down the hill. But where does the problem really begin? Does the hill have anything to do with this problem? No. Not really. Okay, the problem's going to begin down here when the sled reaches the lowest point. So that we're told that the sled has a velocity of 7 meters per second, and then it's going to slide to rest, and we have the coefficient of friction as 0.05, and from this info, what we need to find is how far the sled travels. So we'll just call that x. Now, in reality, this is a kinematic question, right? This is a kinematic question. How far does it travel? We have the initial velocity, we have the final velocity, but is there enough info to figure out x yet? No. What do we need to find? In order to figure out x, we would need to have the acceleration. If we knew the acceleration, then we could figure it out using this kinematic. So we're going to be going v final squared equals v initial squared plus 2ax, where v final is 0, right? And then you take the rest of this, and when you do the algebra, you're going to get x equals negative v initial squared over 2a. But this a is going to come out what? Negative. This a is going to be negative, so the negatives will cancel. Now, why is the a going to be negative? Because we're going to say, well, if we say that this velocity here is positive, that means we're saying to the right is plus and to the left is minus. So as the block moves from here to here, is it going faster, faster, faster to the right, or is it going slower, slower, slower to the right? Slower, 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 which means the acceleration must be negative, right? It has to be a negative acceleration. So how do we get the acceleration? We're going to use forces. So we're going to start with a free body diagram. So let me try to grab this. Oh, wait. I need the lasso. So let's shrink this down. So we're going to do free. Let's stick it over like that. Okay, so we're going to do free body diagram first. So here's the object sliding to the right. So what are the forces on the object? Yeah, we have mg down, which they tell us is 600. mg is 600. Normal force is pointing straight up, and then friction is pointing straight back. And friction is coefficient times normal force. Now, at this point, let's solve for the mass of the block, because we're going to need the mass of the block when we sum the forces. Is 600 newtons. They tell us in the problem that the boy and the sled together weigh 600 newtons. Is that the mass? No, that's the weight. And weight equals mg, right? Weight equals mass times gravity, which is equal to 600. So how do we get the mass of the block? So if mg equals 600, what's m going to equal? 600 over g, where g is 9.8 meter per second squared, and this is going to come out as 61.22 kilograms. And you should know, where did kilograms just pop out of? We got meter per second squared and newton. Well, what's a newton? A newton is a kilogram meter per second squared. So then the meter per second squared cancels, and we get 61.22 kilograms. Okay, so that's the mass of the block. Let's get rid of that. Okay, so we'll just put m equals 61.22 kilograms. Okay, so this is the free body diagram. What do we do after the free body diagram? We sum forces x, we sum forces y. In the x direction here, there's only one force, and that is friction, and we want to make it negative, because remember our sign convention is this. To the right plus, to the left minus, right? There's our sign convention. So we're going to say negative friction which is mu Fn. That's the equation for friction. Any other force in the x direction? Nope. So that is the sum of the forces. And what does the sum of the forces always equal? ma, where that's the x acceleration. And then we go to the y direction. How many forces in the y direction? 2. So normal force minus the weight, which is 600. This is the sum of the forces. Sum of the forces always equals ma, where that's a y acceleration. But is the block accelerating in the y? No. Nope. So we can cross the y acceleration to 0. Just make this equal to 0. Now, the rest of this is algebra. Take this equation. Normal force must be equal to 600. And then take the normal force, plug it in up there, and then you can solve for A. So now we're going to take this equation, right? So A is going to equal negative mu Fn divided by mass. So then you plug in negative 0.05. The normal force is 600. And then the mass is 61.22 kilograms. And this gives an acceleration of negative 0.49, which then gets plugged in up here into our kinematic. So it's going to be negative times the initial velocity was 7, 2 times negative 0.49. Negatives cancel, and our x comes out as 50 meters.
Woo! Yeah! All right.
All right. Thank you. I'll be here all week.